So welcome, guys. We are excited to have you all here. David Murray is a program manager in the Azure SQL Database product group. He has been working in the IT field since 1997 and was awarded Data Platform MVP status for 12 consecutive years. That's impressive. He started his career as a full stack and backend developer, then focused on databases and data science for 15 years, while still keeping alive his passion for development, mainly C# and Python. He now works for Azure SQL as a developer's voice inside the product group, working to make sure that Azure Database is and will be the best database option for developers. Who can disagree with that, right?
Yep.
I want to say thank you, David. I just reached out to you, and you are probably the nicest person. Reached back immediately.
Thank you.
Agreed to do this event, so I have to say, really, I have to be very, very thankful to you. So
sure, absolutely, it's a pleasure.
Yeah, the floor.
Yeah. So yeah, let's get started. Actually, I just have a few slides to introduce what will be the main topic of the session. So you just already said that, so let's skip that. Oh, actually, good that I put the slide because otherwise I would have forgotten. As we were discussing before, one of the book that I just wrote along with other friends and colleagues in the Azure SQL team has been just released. It's basically focused on Azure SQL from a developer perspective. It will cover pretty much what we will be discussing today, plus much more, of course, like column store. It's not something we'll discuss today, or in memory table, but that will be all covered in the book. So if you are a developer and want to make sure that you use Azure SQL in the best way possible, that's the book for you, especially if you are a new developer and never used Azure SQL Server or Azure SQL before, because we start from zero and go literally from creating a new database to the CI/CD pipeline, going through all the options and features that you have available. Today, we will try to do the same, of course, focusing on more specific feature. But yeah, the story will be the same. End-to-end solution with Azure SQL as the backend database for what we want to do. And what we want to do today is to actually create a to-do MVC application. So there is a very nice website, and actually let me go immediately to the website, which is way easier to see. This to-do MVC framework website is a project that allows any developer to see how they can create a front end for a hypothetical to-do MVC application, where you can actually, create a to-do, mark it as a complete, create a new one, and so on. And this is just the front end. Now, this has been so successful that also a backend has been created. So this to-do backend aim to provide a set of standard API that can be easily hooked into this to-do, and so that the to-do will not be saved locally as it happens right now. This is just the front end, so everything will be saved in the local storage of my browser. But if we hook the to-do backend into that project, we can actually decide to send the data somewhere, like in a database. In our case, we will use Azure SQL, of course. So it's interesting because this to-do backend defines the API using a test. So you can actually target the API you have created or you think you are going to create, run some test, and the test actually represents the definition of those API. Now, the API are pretty simple. Let me go directly to the API. So basically what we have to do is to create a set of REST API that supports post, get, fetch, and delete verb. The content will be JSON, of course. And there are just one additional requirement, that when we select a generic list of things, like a generic to-do, we always return an array. So if we do get to-do, we will always return an array. But if what we are doing produce exactly one object, we don't return an array, but we just return that specific object. So this is a little adds a little bit of complexity to our work. But then I also want to add a little bit more of, I wouldn't say complexity, but more make it more realistic. Let's say that at some point, and this is what we are going to do. But let's say that at some point, the requirement will change, which is pretty common in the real world, especially if you're a startup, or especially if you're starting to work on a project in an agile way, where there is not what is called, a big design up front, but it's just an agile approach. So you will do something, realize it may need some change it, deploy again, and so on. So we'll try to follow this approach of iterative development, also with Azure SQL. And of course, this will be what we will be building. So I won't build the front end. I will just use one. Actually, I won't be even building this one. If we have enough time at the end, we will see it. But otherwise, we'll just focus on this part. So the part that interests us is this one, the central one, the API. And the API expected to receive some JSON from the front end. This is the JSON that the front end will send us when we, for example, create a new to-do. And this is what the front end expect to receive, and the API expect to produce, to make sure that it's compatible with the front end and adherent to the set of tests that has been created for us by the guy that created the Todo Backend project. Now, the question here is how we can do this and maybe just keep using JSON with Azure SQL. We know that normally we would have to create a table and add columns and then create a storage procedure. But then what happens if here we add a new property? We have to go and change a lot of stuff. So I also want to show you how we can create a flexible solution with Azure SQL that will be able to sustain any change or any agility that you need in your solution. So let's get started now. I will stop using slide, and there should be enough time to do everything. So what I will be doing is creating, actually, at the end, if we have time, I will also create a web app, but ideally I will work locally, creating a .NET Web API. I could have also used Azure Function. I also have an example using Azure Function, but just to make it a little bit different than the usual, I decided to go with Azure WebApps, also because it allows me to show how to configure correctly cores to run the tests that are being provided by the Todo Backend. And then, as said, we also want to add some agility. So we will try to make it as flexible as possible. And we also want to make sure that we approach the development in an agile, iterative way. So we will create also a CI/CD pipeline using GitHub Action to make sure that every time we decide to push some changes, also test and deployment and test will be executed. So we will get started right away with a solution that is completely empty, right? I just created a repository, cloned it, and now the solution is completely empty. So what I will be doing right now is creating 3 projects, and to speed things up, I will be doing some code cut and paste, for example, for these things that are not specifically important. So I'm creating a to-do API solution where we will be, of course, creating the API, and I created a web API solution. Now I am now going to create a solution to deploy my database, and we will discuss about this later. And also, I'm creating a solution to run the test in my database, because I also want to, of course, have some tests that can be run as part of my CI/CD pipeline. Now, just to make it easier for me to do later, I'm also creating a solution, and I'm adding all these 3 projects in the solution. So it will be just easier to do .NET deploy, run, this kind of stuff. Okay, perfect. So everything has been set up. Let me clear the console, and we're good to go. Now, what I want to do now is start to work on the API. So as you know, when you create a new API using .NET CLI, you will get some boilerplate code for, actually, this API is actually working and is returning some weather forecast. Now, the first thing I want to do is to get rid of this. And now I'm doing something very specific here. I'm completely getting rid of my POCO object for now. Now we can, if we have time, you can discuss this in the future, before in the end. For now, I just want to go without any POCO object. I will just rely on JSON as an output of my API. Now, this can be changed if you prefer to also have a POCO object, but just for the sake of this solution, let's start, or let's at least keep it as simple as possible, which was one of my goals, and just go with plain JSON. So I can get rid of that. What I have to do is go into the controller. First of all, I want to change the name of the file in to-do controller. And of course, I also want to change this name here in to-do controller. I don't need this anymore because these were just samples. And also this, it's not needed. Now in my, and this will be just a JToken. JToken because I can return any JSON, be it an object or be it an array. So since I'm using JToken here, I need to, of course, use Newtonsoft, which is probably not imported. So let me .NET add some packages. So JSON, of course, and then .NET. Yeah, that looks good to me. Nope. Oh, yep. I have to change to API. So let's add that. Now, since I also want to connect to Azure SQL and run something, I also need the library that will allow me to do that. So Microsoft.data.sql client. Make sure from now on you use Microsoft.data.sql client instead of system.data.sql client, because this is the new library. It is actually open source, so you will find this on GitHub, and is the one that is future-proof because all the improvement and all the support for new feature will be done there. So just make sure it's a really drop-in replacement for system.data.sql client. So just make sure you use Microsoft.data.sql client. And then we also need the Dapper. So I also add the package. Dapper is a micro ORM that will simply make our life much easier, because what I can do is, and let me go very quickly to the slide. With Dapper, what I can do is create my POCO object if I want, and then just on the connection, execute a query or store a procedure, and automatically the mapping between the result set and the POCO object will be done automatically for me. So it really removes all the plumbing code, and we don't really have to take care of mapping columns to properties anymore. Now, we also may want to not to map it to a POCO object, just using a dynamic object or JSON, as I will be doing. So Dapper has been added. So what we can do right now is, first of all, I need to make sure that I can, so what happened here to the colors? Let me open this again. And, oh, here we go. Newtonsoft.Newton.json, okay. And so this, let me just close Visual Studio and restart it again, just to make sure that is happy about the fact that I added new packages and everything. Okay, much better now. And let's also add using oh my God, using Microsoft.data. Okay, SQL client seems for some reason IntelliSense is not working. Let's see, client and Dapper. Okay, let's, yes. And to do API. So let's wait for Visual Studio to build everything, and then we should be good to go, hopefully. In the meantime, what I want to do, yep, okay. Yeah, seems all good to me. So I just, again, let me restart Visual Studio just to be sure that it has created everything it needs. And in the meantime, what I want to do here is also add support for configuration. So here I need configuration that, well, that's fine. I will add it manually. Oh, now it should be good to go. Configuration and not help. Oh, this one. Yes, please. Oh, finally it's working. And this will be in Microsoft.config. Okay, now everything is working nice. Perfect. And this will be, of course, conf. So I can access the configuration. And here I just need to also make sure this object gets created for me. That should be it. Let me try to cd todo.api.net build. Oh, there is some error. Oh, JToken. Oh, yes. This is .link. And now that should be able to be correctly built. Not yet. Oh, yeah, of course. But this is something I knew because here we still don't return anything. So for now, just to actually, let's create the code here. So what I want to do is connect to SQL connection for some, oh man. And with the SQL connection, I just need to access the configuration. And here I should be able to do get connection strings, get connection string, and I will create a connection string called Azure SQL. From inside here, what I want to do is just execute something and let me save and return basically the result. So what I will be doing is con dot, and thanks to Dapper, what I can do is do something like single. So let me try to, let me do this for a second because for some reason VS Code has the IntelliSense is not working. So let me close this, and this is usually happens when something strange happens behind the scene, because this is something I can build. Dot to do cd. Oh. Yeah, so there are no errors here. So normally it just needs a restart. So let's see if I have IntelliSense that will help the speed of my code writing. And let's see. Let's see if IntelliSense kicks in. We can take a look at here and OmniSharp. Okay, that should be good now. Okay, so let's see. Okay, so, oh, finally. So what I want to do is query single or default, because what I will be doing is creating a storage procedure, but I told you that I want to make it as flexible as possible. So my storage procedure will not return a table or a result set, will actually return JSON. So for us, JSON will be a string, actually. So it will return a string, and we will also be returning a JSON, right? So we don't need a numerable here, because a JToken could already be an object or an array. So I don't need an enumerable. What I only want to do is make it async, and then I will add a task here to make it asynchronous. This will be the async version. And so I will do await, and here that's perfect. So what I will be doing is the query result is equal the execution of my, and let's say my storage procedure, since I have to implement, I'm implementing the get method, will be called web get underscore to do. And this will be a storage procedure. So I just have to using system.data in order to have the command type available. So command type dot storage procedure. Nice. Now, before executing this, and actually the result will be a string, so the only thing I have to do, and I can do something like that, return jtoken.parse, and if the string is something I can expect to be JSON, so I can just parse it. If will be something empty or null, I will just want to return an empty array. That's it. So this is already something that should work. We just have to add the connection string and create the storage procedure. So then create the storage procedure and the database. So let me create a database right now, and I will be creating a couple of databases, actually, not only one. So the first one is todobc.dev, which is the database I will be using as my personal development space. I could have used also SQL Server running locally, but just for the sake, I'm using Azure SQL. And then I will also be creating another database called test. That is database where I imagine I will commit the work that we are, that all my team is doing around this, with the hypothesis that I'm working on a team, where we'll do the merge of all the database changes, we will run the test and everything. So this will be really something like where we test everything before going production. So I have two databases, one for development and the other for testing. Now, databases are being created. It won't take much. In the meantime, I can go and start here to add my connection, connection string here. Okay, so I'm connecting my database. The database I have created is called todobc_dev. That's it. Now, the only thing I want to do, since I don't want to use any high privilege account, is to create a user that will be used by my backend to connect to the API. And so this user will be this user I have here, to do backend and this strong password. So let me connect to the database right now. Let's see if the database are there now, to do, and here we go. So this is the database I want to use. And here we go. Let me create some object. So I want to create a schema where I will store all the tables and the objects are related to the storage procedure that my web API will be able to call. Then I want to create this user I will be using. Now, let's set this aside for a second. And let me just take the password I decided to use here, this one. And let's add this. So I'm creating the user. I'm giving the user the permission to execute any storage procedure I will be creating. I'm creating a sequence because I need a way to generate numbers. And then now I'm just creating my table. And my table is very easy, right? Since I have to store a to-do, the only thing I have to do is store the ID of that to-do, the title, and if it's completed or not. That's very easy. Now, I told you that I want to allow the web API to access the data via storage procedure to make it more secure and manageable. So I just need to create that storage procedure. But to do that, let me, before, show you something interesting. And so let's add some data to my table. Insert use. Let's insert the title and if it's completed or not, values, and I will do first is not completed and second is not completed. Okay, now what I really want to do is something like that. Select from to-dos, but I don't want the result set, right? I really want to be flexible and allow to the developer to write as less as code as possible here. And here, the idea was to get JSON. So the only thing I have to do is for JSON auto. That's it. That will return any number of rows with any properties. So all the column will be automatically turned into properties for me into a JSON, which is exactly what I want, right? Now, the only thing I don't want is completed to be an integer. I want to be a Boolean. So let me do that. id, and then I will return the title, and then cast completed as bit as completed. Now, I also don't like the name of this column, which is weird. So what I will be doing is basically wrapping this into just one variable, and I can do that by doing a select. And then what I want to do is actually return the result of my select, right? But as, here we go, as result, for example. But now I really want this to be, I know that this is a string, and so I want to convert it to a very long string so I don't have any problem even dealing with the biggest JSON I can imagine. Now, this may not be the best idea for performance reasons, but let's say I really want to be able to handle any kind of JSON. So let's cast this as an varchar max. And here we go. So we have a very nice query that actually returns JSON. Now what I want to do also is make sure that, of course, I can filter out this to-do so that I can only return the to-do that has been requested by the user. So I probably want to do something like where, and let's say id equal something, right? Now, this goes here. Here we go. Now, how can I pass this? Of course, one option would be in the storage procedure to pass a regular parameter. But what if at some point I want to have not one, but 2 or 3, or a set of to-do to be returned? This is not a requirement, but it's probably very, it's highly possible that that will happen in future. And maybe I start to wonder if I can do something very easy to support also that hypothetical requirement. And it turns out that in order to support that, it's pretty easy, because let's say at some point I ask the API to give me something like that. Let's call it J. This must be an varchar max, and this will be equal something like ID 1. So if the backend API will return to will ask to Azure SQL to execute a storage procedure, and they expect to have JSON as a result, it's also reasonable to expect the API to also give to SQL a parameter that is actually JSON, because that will also give us some flexibility, not only getting the data, but also sending the parameter, right? So if I can parse that some way, actually, maybe we can also think that the user will do something like that at some point, right? So this will be an array. So I can do something like that to get to access to data IDs from OpenJSON, and then I will pass my J with, and then I know that the ID is an integer, and I can do that. Here we go. I just now have a way to pass an entire array that can be as complex as you want. In this case, it's just a simple array with just a value to my procedure. So if I accept in the procedure a JSON and manipulate the JSON so that I extract the IDs, it will be very easy here to allow the return not only of one, but any to-do I want, right? So this is exactly what I already did. So let me take the procedure, which is a little bit longer than what I just shown, and let's create it together and let me comment it. So this is the procedure I'm going to create. Let me also copy the comment. So the procedure will accept any valid JSON in this form. The name will be called, the parameter name will be called payload. And we have to remember a little bit the requirement. The requirement tell us that if we don't specify anything, the expectation is that the get on the to-do will return everything. So this is exactly what I'm doing. If the payload is null, or is an empty string, I will just return everything as I shown before without any where clause. If the payload is instead a valid JSON, so I'm not sure I will get any kind of, I won't get any kind of injection. So I validate JSON. If it's JSON, then I will do exactly the query I shown before, where instead, in this case, instead of doing ID equals something, I will just make sure that I will return all the ID that exist in the JSON. As easy as that. So I can create my procedure right now. And I can just try to execute it just to make sure that everything works as expected. So I can do something like ID equal 1, and that works nicely. Perfect. It just returns one object, right? Now, if I add more than one object, like this, two object, oh, that must be valid. Here we go. Two objects will be returned. Very, very nice. Another thing is that what I want to do is, or what this allows me to do in future is, let's say that in future I want to do something like, oh, I want to filter all the to-do that are for which completed is equal to true. Now this now won't return everything because anything because we don't know how to handle that. But this means that without changing the signature of the storage procedure, so it will always still be using one parameter, we can change the internal of the procedure to handle also this case. But this, since the signature is not changed, we don't really have to change any of the code that connects my API with Azure SQL. So this, again, gives us more flexibility and more agility. Now, having said that, let's go here. And what we want to do here is just pass the parameter to my procedure. To do that, of course, I first of all need to allow the user to specify an ID. So here I will create a root that will support an optional ID. Again, just to follow the requirements, and that will be mapped to integer. Very nice. Now, all I have to do is to make sure that if the ID is specified, I pass the payload, otherwise not. To do that, the easiest way is to use an object made available to you by Dapper called the dynamic parameter. And here, what I have to do is check if ID has a value. If ID has a value, then what I want to do is create, add to my dynamic parameter a parameter that is called payload, because this is how we named the payload. So the procedure was something like that. So the parameter is named payload. And it must contain, if you remember, something like that. So what we want to do is create a new JObject that will be created having an ID which is exactly equal to the value of the ID passed, right? But the payload must be a string because SQL doesn't know what an object is. So what we have to do here is do something like toString. Here we go. And now we just have to pass the parameter to the query single or default async. And the parameter is the second option. So I just do DP and that's it. So this should be good enough to have the get method completely working. Let's see if this is true. So let me just do func. Actually, let's debug this so we can also see if there is any error. And nice. So to debug this, oh, actually, let's go for 1 second here to the VS Code tasks and launch. So as you can see here, by default, it will launch a browser. I don't need that. And also we don't have this, so we don't need this too. And I can also remove this. So just to make it a little bit cleaner, and let's call this Todo API. Nice. Okay, now let me launch this again. And let's open Insomnia, which is a very nice REST client. You can use even curl or Postman, your favorite. And Insomnia will allow me to execute a REST call. So for example, here, this has been exposed here. So perfect, I can just call and see if I did everything okay. So let's see what happened. Oh, that's weird. But I perfectly know why this happens, because we are using NewtonSoft JSON, and by default, the latest version of Web API use the JSON engine shipped by Microsoft. I'm a kind of a good old-fashioned guy. I've been using NewtonSoft JSON for a while, so I just stick with that. So what we have to do is go in the startup and make sure here we add support for JSON, and to do that, I just have to make sure that I import this one. And I'm showing you this because right now, right today, or actually a few days ago, .NET 5 has been shipped, and you have to make sure that you actually use the right Microsoft ASP.NET Core MVC NewtonSoft JSON support, otherwise you will get some error. Oh yes, I have to do API, and let's do this again. Perfect. Now this will allow me to just do something like that, using NewtonSoft.json. Then here we go, NewtonSoft JSON as support to serialize and deserialize. That's it. That should do the trick. And here we go. Let's run this again. Oh, very nice. So now we have the result completely serialized into JSON, but also they are sent from Azure SQL to the backend into JSON. I can do that, and everything works nicely. Now, let me show you also something very interesting. Let's say at some point that for any reason, we want to add a new property. Now, let's say that we already have changed our code or even our database schema, but the bottom line here is that I want to show you this. So let's say that in my story procedure that I created before, so let me grab it again. Let's say at some point we want to add a new property here. So let's say that I will return 0 as order. I just also want to return the sequence or the priority of my actually, let's call it priority, of my to-do. So I just need to add it here and here, save. Now my application is still running. And thanks to the fact that I'm relying on the schema returned by Azure SQL and not then matched with a POC object here, what I can do is just do this. And here we go, we have the priority added. So it's very easy to extend the schema on the Azure SQL side to add support for more field, for example. We can also see later if we have enough time, otherwise we'll send the link or put the link, actually the link are already in the presentation, how to make it even more flexible, because one thing you can do is instead of creating the table like I did before, so having the regular table, we could do something like extensions, and then here I have an nvar char, and here just save anything JSON. So we could actually save also JSON inside Azure SQL, and that will allow us to easily extend and change the schema if we want. So there are several ways, at least 3, where we can actually make our schema really, really dynamic. Now, having said that, it seems that everything is working. Now, I really want to be sure that is working. And the guy at the Todo Backend also provided this specs running I told you, right? So this a specs runner, which runs some tests using Mocha, JavaScript framework, can also be downloaded on your local machine to run tests locally. So this is exactly what I did already. So let me add a folder to the workspace, and the folder is just this one, Todo Backend JS specs. And what I can do here is, if you have downloaded a extension called Live Server, okay, so if you have that extension, what you can do is just go to this index, right-click, and do Open with Live Server. This will open the browser with the test running that you can just point to your local API. And my local API, we know, is HTTP localhost. Now, as the most experienced of you already know, this will not work because we have CORS that will prevent the website to work because we are doing a cross-origin request. So we need to configure CORS. To do that, let me stop my code, go to, okay, sorry, I have some Zoom weird thing here. Okay, that's fine. What we need to do is to go here and make sure that we enable CORS. Now, to do that, it's quite easy. At the end of the day, we just have to make sure that we configure the origin, to make sure that we allow our website that works at localhost 5500 to connect to our API, and then we just have to use use the defined policy, and make sure you place it after authorization. Now, the other thing that we want to do, at least locally, is to make sure we don't redirect to HTTPS. Otherwise, again, in this specific case, I'm just allowing HTTP, not HTTPS, so it will not work. Now, with that done, we should be able to have our test running. Let's see, refresh. The first one should succeed. Perfect. Now, we didn't implement post, we didn't implement delete. Of course, the tests are failing, but that's exactly what I would expect, right? And now that I have several tests that I can understand, for example, I should be able to create a post, and then this test will prove that my implementation is good. I can run this test to make sure that I'm implementing the specs correctly. Now, of course, unfortunately, for how these tests are done, or at least maybe I'm not so expert with Node and JavaScript, there is no way to run this test within the CI/CD pipeline I will be deploying on GitHub. So I need to convert or create some additional test that will allow me to simulate the specs generated by the JavaScript test. So it's now time to start to create a test here. And here I've been creating my project using NUnit. So let's just call it Todo API. And what I want to do here is to make sure that I will be able to execute some test against my my endpoint. So let me just go and grab some code here, because otherwise it will take just too much time. And actually, let also me do that. So I can have the help of IntelliSense. So let's go to CD, to do and test code, and that's it. Don't save, I don't need them. And perfect. Okay, so the first thing I want to do is to make sure that my test will be able to actually create the controller for me, right? So I need to make sure that my test project can actually reference my API project. So I'm just adding the project reference here. Yes. And let me save this. After that, what I want to do is to, of course, add some, actually add some packages that will be needed in my code to run the test. And specifically, I will need these packages. Dapper, probably I don't need it, but definitely I need the environment, data client, the logging, and JSON. So let me save this and do a .NET restore again, so that now I can start to add some code without having Visual Studio complaining. And the first thing I want to do is this. So the setup will be executed for each test. I need to set up something before any test is running, only one time. So to do that, NUnit allows me to execute, create a method, mark it with a one-time setup attribute, and this will actually be executed only one time. Now, let me also add some other using directive. Here, what I'm doing is reading from the .NET env file that I will be creating immediately, so that the .NET env will actually put in the environment the variables for me that are found in this file that I will show you in a few seconds. I then create the logger so that it will log to the console. I will create an in-memory configuration so that I can inject into the configuration the connection string and Azure SQL that the API expects to have. Because if you remember, our API are reading from the connection string, a connection string called, let me, new window, called Azure SQL. That's it, here we go. So our API are actually waiting and looking for a configuration called Azure SQL. So we need to simulate something like that using the in-memory provider. So that's exactly what we are doing here, creating into the connection string a connection string called Azure SQL. And then I'm creating the controller. Now, my test now is as easy as this one. So I want to simulate the same test done by the JavaScript framework. So what I'm doing here is creating a test, respond to get, which is very similar to the test that has been done here for me, which is right now. Let's see if I get work. And then check if the result is an instance of array, because I know that by the requirement, if I ask everything, I should get an array. Maybe an empty array, but an array. Now here, this is something I don't like, but that's how the original tests were made. These tests need to be run in that specific sequence, because some test requires some other tests to be executed before. So that's why here I'm also specifying the order. That's it, that should be it. Let's see if everything's compiles. I see some errors, so let me .NET build and see what errors are there. Nothing, perfect. So as usual, I just have, oh, let me save this. I didn't save it. So let me build again. Oh. Very nice. Now, if everything works correctly, and first of all, let me show you what is in the environment file. The environment file contains the connection string that I want to be injected into the endpoint API to run the test somewhere. Where? In my database. Now, the database I'm using right now is this one, is Todo BC dev. So I just have to do that. Perfect. And I just specify the user ID and the password here, and that's it. Now, if everything works as expected, I should be able to do something like .NET test, and it should detect one test, run it, and let's see if it works or not. Nice, my test has succeeded, which is exactly what I would have expected, because this test succeeded too, and I'm just creating the same test to replicate the test you see in the video right now, and that are the tests that are provided as support of the requirement. Now, the last thing I want to do here, since in my local environment everything is working, is start to publish this to GitHub, right? Because then at some point, I started implementing the get method. I'm happy. I want to start to deploy that. And then I will implement the post and all the other. So to do that, I need to go now to another project called the one that I already created before called deploy. And here, I will be using a very nice tool called DBUp. Now, DBUp is a nice package that will allow me to apply to a target database a series of scripts in the correct sequence and making sure that one script is never applied twice. So it will take care for me of, again, the low level or low value action that are still needed in order to make sure we can deploy something correctly. So first of all, I want to create inside this project a SQL folder. And inside this SQL folder, I want to create the file I want to be used to create my database when I will deploy my database for real. So I am creating a file that contains the object we already used with this specific keyword that we will see. And I'm just anticipating a bit. I'm also creating a file that contains all the procedure just to show you how this works. And inside the program, all I have to do is do a .NET add package DBUp, and then start to use DBUp, which is pretty easy. One other thing I want to add is Microsoft.data.sql client, and I will explain. This is not strictly needed, but I found it very helpful, and I will explain you in just a minute why I think it's so useful. Let me grab all the code here since we are running short on time, and let me do that. So what I've created, and of course I also need my .NET env package. So here we go. Okay, here I need to use .NET env, DBUp, and the various libraries I need. So here is to load, as usual, from an env file that I'm going to immediately create here. From an env file, everything that will be then used, get from the environment variable. Why I'm using the environment variable, I will explain in 2 minutes, and it's related to the fact that GitHub Action heavily rely on environment variable. So I want to prepare something that's easy to be deployed also to GitHub Action. I'm reading my connection string, and here I'm just opening and closing the connection. Because DBUp, if you cannot connect to a database, it will simply return a object not found or object not reference to a null object error, which is not very helpful. So just testing before executing DBUp, which is something that happens here. If you can connect your database, is a best practice, so you know if your login in your database is accessible. So I'm just testing the connection, and then I start the deployment. And the deployment uses this deploy changes object from DBUp that says, deploy the changes to this database. All the files that must be used for deployment are inside the SQL file. Create a system table that DBUp will be using to keep track of which script has been applied already and which not. And then inject this, change the value of this DBUp variable with the value that you take from this, because this will allow me to avoid to store inside my my script a password in clear text. So this kind of $, this pattern will be recognized by DBUp and will be replaced by the value that I have stored in this variable. I want to log to console, and then I just want to build a set of steps needed to deploy the database, and then I just want to apply the steps to my database. So let's do that. In my environment, I created a connection string In this case, I'm pointing not to my development database because I already deployed everything, but to a new database I created before, so we can see what happens together. I'm using, the only thing I need to do is to use a higher privilege user here, because this user must be allowed to create objects. So I just need to connect to my test database and create that user before. So let me do that. Let me go to the server, find my database here, and create the user, which is this one. New query, create user, and that's it. Perfect. So this user has enough privilege. It's actually DB owner, so it's a kind of a local admin to create everything it needs. And now that should be it. The other thing that I want to show you is that in the environment, I also added the user used by the To-Do API to connect to database, because this will be the user that will be created to allow the backend API to connect to the database. So I just want to avoid to have this visible somewhere in my script, because this env will not be something I will be deploying in GitHub. So this is something that will only stay on my machine. Perfect. So let's just run this and see if it works. .NET run. I don't see. Yes, okay. Oh, something didn't work. Oh, it's connected to the wrong database. So good that I added the code that I mentioned before. So let me close these two stuff here. And this is just to do BC one, right? Yeah, to do BC test. Perfect. All good, all good. Let's try to run again. Very nice. So this has executed this script and this other script. So the result now, if I go here and do select from this.objects where ns is equal 0, you will see that a bunch of objects has been created for me. And so here I can probably do select from to do, and of course it will be empty now. But this means that everything has been deployed. And there is this table. This table called DB journal that contains information about which script has been executed or not. If I try to deploy this again, nothing will happen because both the script has been executed already. So you will see nothing will happen. Very nice. Now let's go back to the original solution I created, this one, where you can see all my project here. Let me close some stuff. And what I want to do is to start to push this to GitHub. But I also want to make sure that every time I push my repository, I deploy my database to the test database and run my tests. So what I want to do here is just create a new folder called .github, and inside this folder, workflows. Now, again, I just do copy and paste for now, and I will use a YAML file that says, dear GitHub, use your GitHub action, which is the CI/CD pipeline provided by GitHub, to make sure that every time I push into the test branch, you check out the repo, set up .NET Core, restore the dependencies, and then do a .NET run of my deploy solution that we know we will deploy the database. The connection string and the backend user will be environment variable that will be created for me by GitHub action, taking the value from some secrets. So let me go and create the secrets here. So I will go here. Let me go to GitHub. That must be somewhere here. So let's go to settings and let's go to secrets. New repository secret. My secret was my Azure SQL deployment connection string. So the only thing I have to do is go here and take this connection string. And I am deploying into the test database. Perfect. Now I have other two secrets to create. One is the connection string used to instead run the test. So let me create the connection string to run the test, and let me just grab the connection string, and that's it. The only thing I have to make sure here is that I deploy to test in this case, and that's it. Now, last one is the password for the Todo Backend user that will be created for me on the test database. So let me just go here, take the password, go here, type it here, and then make sure that I correctly name the secret. Here we go. Nice. Okay, I'm ready now to do this. So let's say git status, bunch of things to add, git add and git commit, first commit, and then push. And let's see what happened. So this is adding everything. I already changed it before the GitHub, git ignore to avoid to commit env and the development JSON. So what I expect here is that if we go here and I go to action, yeah, you see now there is this workflow. And let me see. I was expecting to see something happening here, but I guess, yeah, you see, I was in the main branch, my bad. So let's do git git branch test, git checkout test. Okay, so let's just do one simple change. Okay, so git add, and let me do all this. Now let's do a git push so that I will be given the code to also add the remote one, and that should be it. So with this done, we should be able to see now something happening. Perfect. Because I decided to only monitor the branch test, and I forgot when I started the live coding session to switch to the correct branch. So this is now deploying my database. Now in this case, it's targeting test, and just for the sake of showing you how DBUp work, I already deployed everything. So here, I don't expect to actually deploy anything, right? But then it will connect to the deploy database using the same credential that will be used by the web API and run the test. So let's see, database has been deployed, and now perfect, everything worked. And let's see, the deploy script will probably say that there is nothing to deploy. Now let's run the database. And yeah, we are just 5 minutes late. I will just do a very quick change and then recommit everything, and you will see just one small change, just for the sake of seeing everything in action. So let's see the test. It should take just a few seconds, and it should work because we know it was working before. So one test found, perfect. And yeah, perfect. Total test passed, so we are good to go. Now, what I can do here, let's say I want to create a new change my story procedure, for example, to add, like we did before, here we go, like, you know, change this to support a new field. The only thing I have to do is do something like as priority. Now, one thing, of course, is that I cannot just change this file because that won't be applied, right? So I can take this. Now I can create a new file, call it 003 updates.sql, for example. Put here the code to deploy the updated procedure with the priority, right? Also here, maybe, just to make it coherent. Now, I will do something exactly like I did before. Updated, let's do updated SP. That's it. Now it will do everything for me. We will deploy, it will do the test. Probably I should also add a new test here to make sure that I correctly test for the existence of this. And everything will happen automatically for me. So if I go here right now, you will see that this is working. So at the end of this, you will have a complete solution that I actually already created for you. It's available, completely finished. Is this solution here, where you have support for all the to-do and verb, so the post, the get, the patch, and the delete. And the result of this approach is that not only you can deploy the database, but you can even deploy, and if you download and clone this repository, you will have everything. You can even deploy the web application. So each time I do any change here, I deploy the database, run the test, and if the tests are correct, because I put a constraint in order to deploy the app before, it will deploy the app, and my app will be up and running. The result is that my app is actually already up and running. It's here, and this will just, oh, not this one, this one. Here we go. So this will, this will return, some values I have in my database right now, which means that if I did everything correctly, I can just take, go to the Todo Backend, open the spec runner, and here, take my API, run this, and this should run everything correctly. Very nice. There are something missing here for you to complete if you want to just extend the schema, so we support the to-do order. But another thing, a nice thing we can do is just go to, again, this website, and here go to client. This client will actually ask you the address of your API, and here you will be able to actually have a front end that connects to your API. Now, my API are running in this other database, since I already have prepared everything. Okay, so let me do select from. Okay, so let me do that. So let me do delete from dbo.todos. And, yep. And then do insert into dbo.todos, title and completed. And let's do value demo 1. Now, if I go here and just click refresh, you will see that now it's completed. If I finished, and let's go back here, you will see that now this is here. And all exchanging JavaScript from the front end to the back end to Azure SQL back and forth, simplifying a lot, really a lot, the code needed. Because at the end of the day, the code needed is to run the API is literally this. So there is probably few things on earth simpler than that. And this gives all the flexibility and the agility we need in order to add new field, return new field, support more parameters. So it's very flexible, very easy, perfect if you want to have this agile approach. Now with that, I a little bit late, but I am done here. So I don't know if there are questions, everything was clear. Let me go back to the slides, and yeah, here you will have some link and everything needed to also you know, have the reference of the product I use, DBUp, and NUnit you already have within Visual Studio Code, and so on. And the code for that is here, this one.
So just quickly, is there any reason why you picked Dapper over Entity Framework?
Yeah, they are two different things. So Dapper is actually a micro ORM, which means it doesn't do anything of what Entity Framework does. Entity Framework is a full-featured ORM. So it provides you a lot of additional stuff in order to, for example, work with more unit of work, or it allows you to completely create queries for you without you to having to write any T-SQL code. Dapper won't do that for you. Dapper is just a very simple tool that will take your query and map it or to a POC object or just to a string in our case. That's it. So if you want to use an entity framework, absolutely, that's another option. Yes.
Are there any other questions, folks? I don't see any here, David. So this was great. Lot of topics. I wasn't familiar with the DBUp, so good to know that there is a tool like that. That you said it makes the developer life easy.
Yeah, that's the idea. Yeah, DBUp is very nice. I really like a lot, and also I'm using NUnit for starting to add into my mind the idea that we also should test the database. And actually with NUnit, NUnit was not done for database, but can be adapted to it pretty easily, as you saw. So that's also a nice thing.
Okay, thank you, folks. And David, I'll reach out to you in the email with the recording link, and then
yeah, absolutely.
Then we'll publish it.
Thank you very much. Have a nice evening, everyone.
Thanks a lot.